Hey guys, all right, so the next step of your project is to plan your experiment. It's very important that you plan and develop your experiment before you actually do it. So once you've created your design, we need to develop this experiment. We're going to try out our turbine in 3 locations, in the open plains, on hills, and offshore, to find out where it functions best. Because now I've built a wind turbine, I want to know where to put it. Should I be looking for one of these 3 sites? So in my experiment, I'm going to take my windmill and I'm going to run it through the simulation in each of those 3 different locations. So at that point, I have to name my variables. If you haven't done any of this yet, I highly suggest you go back to the section on the classroom about variables and do the SpongeBob worksheet. Try to figure out how to name variables. But essentially, the independent variable is the one thing that's going to be different in each one of my trials. I'm going to run 3 trials, and I'm going to record data for each one of them. If I go to my spreadsheet here, it might help you see what we're actually what we're working towards here. Here is the turbine features that I recorded in my last video. And I'll justify them just so they look nice. And then over here, I've got the locations I can do this, right? I'm going to do it in these 3 different locations. I'm going to run this windmill, and I'm going to generate the number of homes powered by each one. So putting a name to those variables is very important. So my independent variable is going to be the thing that I change in each one of my trials. Only one thing is going to be changed in each trial of my experiment. What is it? The dependent variable, I tend to say it's the thing I measure. What am I going to be counting when I'm done? And a lot of people get confused when I say that because they're like, well, they think of a measuring tape, and what am I actually measuring? And so they're like, is it the height of the tower? No, it's not a thing I'm actually measuring with a measuring tape. It's data I'm collecting. What am I counting? What am I recording? Why am I doing the experiment in the first place? What am I hoping to find out? That's my dependent variable. And it's going to depend on the independent variable. So whatever that thing is that I'm changing in each experiment is going to have a direct impact on the dependent variable. The constants are the things that are going to remain the same in each edition of my experiment. In each trial, there's going to be some profound lists of things that are the same. There's going to be, glaring objects that are going to be the same in every piece of my experiment, and only one thing that's going to be different in each trial. Okay? I'm not going to say more than that because I feel like I'm throwing the answer at you right now. But those are my variables. What are those variables going to be in this experiment? And once I have those, it's important that I make a hypothesis. Now, your hypothesis doesn't have to be correct. It doesn't matter at all if your hypothesis is correct. My wife did her graduate research for 2.5 years and came up with almost no results. That's okay. Her methods were new and no one had ever tried them before. And so she was published on that, not on the actual results of the experiment. It's okay to be wrong. I can't stress this enough. Be wrong. I've made 1,000,000 errors in my life. You will too. Learning from them, admitting them is very important. So just make a hypothesis. Where do you think your windmill will function best? Will it function best on this hill, the highest point in Rhode Island? Or is it going to function best in a big flat plain over an island? Or is it going to be best offshore towards the entrance of the bay? Where's it going to have more wind? Where is your blade going to be better in that spot? Do you have a really heavy wind that's good at catching small amounts of stuff? If it's shorter, is that better on top of a hill or on a plain? Where do you think your thing is going to land, and why do you think it's best there? And that means you have to stop and think about the features in that area. What do you think the wind is going to be like in a city compared to the wind over the ocean? What kinds of features might slow the wind down? What kind of features might speed the wind up? What kind of things, like, again, you have limited knowledge, but that doesn't mean you can't take an educated guess. So, and then defend your hypothesis with some evidence. Why do you think that's true? And you can use evidence from the design of your windmill, your explanation of forces from the very first videos. You can use any previous knowledge you might have. You could research knowledge about the wind in those areas, Google it, and find out what the wind's like in those 3 locations, and then use that evidence to back up your claim. And then once you've done that, we can run the experiment. Now I'm going to open the simulator. This is the first time I'm going to open the simulator. And when I run the experiment, I'm going to let it load. Begin. I can read the introduction and then move on. And now it doesn't matter which one of these 3 locations I pick, although I will say this might be nice to look at first. It does give me a little blip about how these different areas function. Some of them cost more, some of them have more wind, some of them, and it gives you a little rundown of the maintenance. Obviously, maintaining things offshore is difficult. And getting up a mountain is not as hard as being offshore, but it still is a pain in the neck. So I've got these 3 places. It doesn't matter which one you pick, you're going to do all 3 of them. So I'm going to click on hills. I'm going to start there. And then I'm going to go in and insert all of the values that I already selected and recorded here in my spreadsheet. So the blade length, I said I was going to do 37 meters. The pitch was going to be 10 degrees. The twist, yes, there was going to be a twist. The tip was going to be thin. The airfoil was going to be thin. And the turbine height was going to be 80. Now, if you look at the page now, I will say that as you change these features, it gives you a breakdown of the way these look. This might be a great time to take a snapshot of the screen. Now, I'm not sure how you do it on your Chromebook, but I know I have this little snipping tool that's a part of Windows, and I just click on New, and I can create a little snapshot of my screen and save it as a picture. And I might be able to insert this later on in my slideshow when I want to put in a nice picture to back up my decisions. It'll give my slide some more energy, make it look nice. So anyway, once I've done that, I can test it, and it's going to calculate my performance, and it tells me I power 193 homes, and it gives me all these values here, which I'm going to need. And then I click next, and I can pick these things. I said I was going to use the resin and the filler, and I think I said no to everything else. And it gives me now 187 homes, and I click next. Gives me this little animation while it does some calculations for me. And it gives me the review. This data here is what I'm looking to collect. Now, you could go in and just add this information right into your slideshow over here. I have watts produced. Where is this? This is the hills, right? So watts produced, I made 281, 211. Oh, why isn't it filling it in? 281. There it goes. 281, 211. And I could go down the swipe area, 4301. So I can go down and I can fill in these values all the way down this list, and it's going to start to fill in this region here. I can also click on export, and it'll download a document that looks like this. And this is just a snapshot of the same information right here. The location, the blade length, the pitch, the twist, the tip shape, all the way down to watts produced, swipe area, air density, air velocity, efficiency, all of this information. So you can gather it either way, whatever's easier. And then once I have one of them, I'm going to go back and start a new design. I'm going to choose the planes. I'm going to insert all the same information, test it, insert the 3M parts, test it, and I'm going to get the numbers for that one. But again, I'm gonna choose the same values that I did the first time. I'm not changing my windmill at all. I'm choosing the same values. I've had a number of students tell me already that they used the same, that they changed the values to maximize in each situation. That's not what I want you to do. I want you to use the same windmill in each spot. We're trying to figure out, where does your windmill work best? And then collect all that data and put it into the spreadsheet. And now I'm going to end this video. In my next one, I'm going to talk about the data analysis and how do I create a graph in Excel that I can use in my spreadsheet, in my PowerPoint.